and in this video I'll give you a quick overview of a new product called the Aurora Gateway CS, or just agateway CS for short. It provides secure remote alarm monitoring over HTTPS for Avaya/Nortel CS1000 systems. The agateway CS is deployed as either a Linux or a Windows appliance on the customer's local area network. So let's get started. In this demonstration, we'll be using a Raspberry Pi 4 running Linux Raspbian. You can download a copy of this Raspberry Pi image from the Alarm Track support site. Once powered up, the Raspberry Pi will automatically create a couple of files in the root CS1000 folder. So we're going to go ahead and take a look at that by looking at the file manager using the sudo I pcmanfm command to open up the file manager. Within the home folder, we'll see it has an agatewayCS folder. We'll open that up, and we can see we've got logs folders, a backup folder, and a few files that it creates at boot up. One of them is the devices file. The devices file is used to identify the individual devices that you'll be monitoring. In this case, it picked up the Raspberry Pi 4 as the primary IP address, using an IP address of 169.254, blah, 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 as you can see there. The only file we really need to edit is going to be the app settings file. The agateway CS comes all ready to receive alarms and will receive alarms right off the bat. But what we need to do is tell the agateway CS where we're going to send these alarms, whether they're going to be sent as SNMP traps or over secure HTTPS to the Alarm Track API web service. So first thing we'll do is we'll open up the app settings.xml file. And I'm going to replace the https.secure.servername.domain name with an actual web service name, which we happen to be using securealarming.alarmtrack.com. And typically what I'll do is just to verify I've got this URL correct, I'm going to highlight the whole thing, I'm going to copy it, I'm going to open up a Chromium browser, and we'll pop it in there and make sure that I can get to the web login page, which I can see right there, so we know the URL is correct. So I'll go ahead and close that. One other thing we're going to want to verify here is the device name for the USB to serial converter. If this is your first USB COM port, the default name will be dev tty USB 0. So we'll just leave that alone. I'm going to go ahead and save this file, and I'm going to close it up. Then we're going to go ahead and close everything up here, and I'm going to open up a new command prompt. And first thing I need to do is I'm going to stop the agatewayCS and restart it in debug mode so we can watch what's going on. So to stop the service, I'm going to issue the command service agatewayStop, and this is going to prompt me for the Pi password, which we are using the default password, which is just Raspberry, and the agateway service is now stopped. So we're going to want to open this in the debug mode, and the list of all these commands, by the way, can be found under the Getting Started HTML file right here on the desktop. Most of these commands you'll be able to see setting up here, but what we're going to do is we're going to use this command, the sudo etc initd agateway.sh, which is the script file we've got loaded, and we're going to run it in debug mode. So I'm going to copy that. I'll close that from the command prompt. We'll paste it in. And this will start the Gateway CS in debug mode so we can watch everything that's going on. And I see that it did find the web service at HTTP thing, and it also now just generated a new trap message, or I should say web message, AUR 100 to you Nortel techs. That is not a normal alarm. That is one we made up just for the Aurora Gateway or the Gateway CS. This is to notify the web service that the Gateway CS is operational. And we can verify that the alarm was received on the web service by, I'm going to go ahead and log back into the web service as we did before. I already have my login set up. I'm going to log in. I'll take a look at the all alarms page. And the most recent alarm that came in, here we are, the AUR 100. It's going to use a new site name, which is going to be device at the local IP address of the device, or a private IP address of the device, followed by the public IP of the device, just so you will have a way of identifying it. And while we're in here, I'm going to go right in on site profiles, and we're going to rename this. So the original default name should be device at 185. I'm going to go ahead and rename this, and this is now going to be named, I'll call this Riley CS1000. Better if I could spell. I'll take that. Back to the all alarms page, and as you can see, now our new site name, Riley NYC Lab, CS1000 is now there. So now all new alarms coming through that serial port will automatically be associated with that name. So we're going to go ahead and minimize here. And we'll be able to monitor the alarms as they come in. I happen to know that there is a DS1 circuit that is about to go out because somebody just hit a telephone pole outside the building and we heard a big boom, and I think we're probably going to see an alarm come in on that DS1 circuit rather quickly. So we'll just go ahead and wait on here, and hey, there we go. We got a DTA 21, and as we see down here, the primary web service successfully received the trap. We'll be able to verify that and any new alarms by going back in and looking at our Chromium alarms. There's a DTC 012. We'll come back in here. We'll do a quick refresh. And as you can see, there's our DTA 21 and our DTC 012. These are both open alarms, and service tickets have now been opened for that DS1 circuit that is down using loop 1. Now, what we're looking to do here now is we're going to go ahead and minimize this, and I happen to notice that there are a couple of guys out there getting ready to fix that circuit, so we assume that that DS1 circuit is probably going to come back up any moment now as they finish splicing the circuit in. And there's our DTA 22 alarm that just came in, and a DTC 103. It looks like that circuit is starting to come back up. And there's a DTA 007 on loop 1 and DTC 103 on the primary clock source. So now if we go and take a look at those alarms and refresh it, we'll see that the loop 1 is back up, clocking source has been reestablished, and all associated alarms have now been cleared in alarm track, and any dispatch operations have been canceled. So let's go ahead and take a look at some of the log files that we've generated. So I'm going to go and open up the file manager again. And under logs, as you can see, we have a serial log, we have event log, we have an alarm log, and a blocked log. The event log is probably the most informative log out of them. This is going to give us everything from this particular day. And we can scroll all the way down to the end to see the last thing that happened. Last thing that happened was this DTA alarm, and it's telling us where it's coming from. All of the alarm variable information that it posted up to the web service over HTTPS and received. The next file we want to take a look at is the serial log. This is just a monitoring of the serial port and what came in, what went out. The alarm log is the error codes that passed the alarms table and were sent up to the AlarmTrack API web service. And the blocked log are a list of the alarms that were blocked and not sent up to the web service. As you can see, we've got overlay alarms, we've got audit 000s, which are pretty common, we've got time updates, we've got a bunch of stuff in there. It's going to ignore these because they happen to be in the blocked table, which if we go back one more, we can see the Nortel alarm XML. This is the actual data set we use, and it contains wildcard characters or full alarm codes or error codes that we are going to block. Anything in this list will be blocked. So any audit XXX files or error codes will be blocked. Any time will be blocked. Overlays will be blocked. Any bug messages that start with bug 5XX or bug 6XX are blocked. Daily routines, data dumps are blocked. All the things you really don't want to see. You can feel free to add any other combination to these to this Nortel Alarms XML file, and they will also be blocked. Next we want to look at is see if we can receive alarms over SNMP traps. So we'll close this up, leave the default monitor up, and we'll wait and see if a trap message comes in. And look at that, we've got an INI 0000 coming from a device located at IP address 192.168.1.104, and that alarm has been sent up to the web service successfully, and we have the received the trap message right here. So you can have any number of IP-based devices that can send SNMP traps, point them to the Gateway CS, and those traps will be encapsulated within the HTTPS request and sent to the AlarmTrack API web service for processing, as well as any alarms received over the TTY port of the CS1000 itself. So that wraps up this brief introduction of the Gateway CS. If you would like a copy of this Raspberry Pi image for evaluation purposes, please contact your AlarmTrack support representative or email us at support@alarmtrack.com. Thank you.